Neutralization reactions occur with an acid and a base, where the acid donates a proton and the base accepts it. So H+ is transferred from the acid to the base, and the products can be a salt, or an ionic compound, and water. Salt and water are both neutral, so it's called a neutralization reaction because you start out with an acid and a base in your reactants, and you end up with neutral products. It's also important to note that water isn't always a product in neutralization reactions, so to figure out what your products are, transfer the H+ from the acid to the base and just see what you end up with. Let's say the acid is HCl and the base is NaOH. H+ would be transferred from the acid to the OH- in the base to form water, and whatever's left over forms the ionic compound, in this case NaCl. Hydrochloric is a strong acid, so it dissociates completely into H+ and Cl-. And sodium hydroxide is a strong base, so it dissociates completely into Na+ and OH-. Sodium chloride is a soluble ionic compound, so it also dissociates in solution. And water doesn't dissociate very much, so we'll leave it as is. When the equation is written out like this, we can see that there are ions that remain unchanged during the reaction. Those are the spectator ions. They don't actually participate in the reaction, so we can cross them out and write a net ionic equation. In this case, the spectators are sodium and chlorine, and the net ionic equation is H+ and OH- make H2O. The next example gives us nitric acid and calcium hydroxide. Nitric acid donates H+ to calcium hydroxide to form water, and what's left forms the ionic compound calcium nitrate. Now don't forget to balance the equation. The previous example, the equation was already balanced, but this one isn't until you add the coefficients. The net ionic equation is similar to the previous example because nitric acid and calcium hydroxide are a strong acid and a strong base, so they both dissociate completely. Cross out the spectator ions, or the ions that don't participate in the reaction. And remember, we know when they're spectators if the charge and the phase remain unchanged during the reaction. In this case, calcium and nitrate are the spectator ions. Then write out the net ionic equation, which is 2H+ plus 2OH- yields 2H2O. But this can be simplified to just H+, OH-, and H2O. The last example gives us formic acid, which is HCOOH, and potassium hydroxide. The acid donates H+ to the base to form water and the ionic compound potassium formate. The net ionic equation is different from the two previous examples because formic acid is a weak acid, so it doesn't dissociate very much. That means when we cross out the spectators, we need to remember to keep the weak acid intact. Potassium is a spectator ion, so we can cross it out, and we can write the net ionic equation as formic acid and hydroxide form formate and water.